Alright, good day everyone. So let us talk about point of inflection test. So this is the PIT. This is a differential calculus. So the point of inflection test. What is the point of inflection? So a point of inflection of a curve y is equal to f of x is a point where the function changes its curvature or concavity. So that means that if the second derivative changes, so we have to take note of this one. If that second derivative changes from positive to negative, or the second derivative of the function changes from positive to negative, the curve changes from concave upward to concave downward. When the double derivative of the function changes from negative to positive, the curve changes from the concave downward to concave upward. So if we're going to look at on the illustration, it means that the point of inflection here is the point Q. So this is the point of inflection where the function changes from the curvature. So from this one, it changes to this curvature. So this one, point Q, is a point of inflection. Okay, so to find the point of inflection, the first step is we have to compute the first and the second derivatives of the function. So this is the first step. Second is we have to set the second derivative is equal to 0 and solve for x, which are these are the possible points of inflections. And the third step is we have to test the sign in sign of the second derivative on both sides of each point. If the second derivative changes sign from the point positive to from up to negative or positive to negative, the point is an inflection. But if does not change, it means that is not an inflection point. So we have to take note, if the sign changes, the point is an inflection, and the second one, if does not change, that is not an inflection. The second test is that if we're going to have the third derivative, the fourth step. If that is the third derivative, when you substitute that one at that particular point of possible points of inflection, it does not equate to 0. It means that is a point of inflection by the use of the third derivative test. So we have to recall about these are the steps in finding the point of inflection. The first is compute the first and the second derivatives of the function, set that one is 0 and so for x, and that's the sign of the double derivative, and we have to use the third derivative when it's not equated to 0. So it's not equal to 0. So it's supposed to be that this should not be equal to 0, that these points are to be called as the point of inflection. Let us have example number 1. Find the values or values of x for which the curvature of y is equal to x raised to 4 minus 4x cubed has points of inflection. So the first step that we're going to do is we are going to find the first and the second derivative. So this is the first equation. Let us transform it one into function. F of x is equal to x raised to 4 minus 4x raised to cube or 3. So first derivative is equal to, this one will become 4x cubed minus 12x squared. So this is the first derivative. And we have to test for the second derivative. Okay, we have to find for the second derivative. We have here 12x squared minus 24x. So this is the second derivative. And we have to set this one is equal to 0. But before that, we have to factor this. And the factor of this one is 12x x minus 2. So we have now, we have to set this one f double prime x is equal to 0. So we have to equate this one. So the resulting one is 12x x minus 2 is equal to 0. So both sides or this we have to equate by 0. So 12x is equal to 0 and x minus 2 is equal to 0. So x is equal to 0 and x is equal to 2. So these are the possible points of inflection. So if we're going to use, okay, here. So that we can find the interval of this. So we have here from x is equal to 0. This is 2. So we have to find the interval here. Okay? So the interval would be from open to negative infinity to 0, closed, and 0 to 2. This is the second interval. And the third interval would be 2 to positive infinity. So these are the interval 1, interval 2, and interval 3. Next step that we're going to do is we have to test these intervals, whether that one is upward or there is would be the change of sign from upward to downward, then downward to upward. So let us have now this one, the first interval. So let us have the interval, the test of x, and the double derivative and concavity. So the first is from this interval 1, negative infinity to 0, close to 0. So we could test using negative 1. So the function, if we're going to have this one as double derivative, in this function, negative 1, basing on the second derivative, we have 12x squared. So 12 negative 1 squared minus 24 times negative 1. So the resulting of this one is equal to 36. So the second derivative is greater than 0. If this is the second derivative of a function is greater than 0, so we can say that the function is concave upward. Okay, up. The second interval would be close to 0 and close to 2. Interval 0 to 2. So we have the test of x or test x. We have here 1. So double derivative 1 is equal to 12 times 1 minus 24 times 1. So 12 minus 24 is equal to negative 12. So the function, the double derivative is lesser than 0. So therefore this is downward. And the third derivative is that 2 to positive infinity. So this one, the test here could be 3 because this is within the interval 3, which is double derivative is equal to 3, 12 times 3 minus 24 times 3. So we have here the resulting of this one is 36. So using calculator, you have 36. So therefore, the double derivative of x is greater than 0. So therefore, this is up. So we have to look out for this concavity of this one from up, down, and down, up. So we could say by the definition of second derivative, if that changes or the sign changes, it means that is a point of inflection using the second derivative test. But if does not change, it is not the point of inflection. So in this case, we could say that these are the point of inflection at x is equal to 0 and x is equal to 2 because it changes the sign from up, down, and up, or it from positive to negative. So positive 36, negative 12, and it becomes 36 or positive 36. So therefore, it changes the sign. So therefore, these points are the point of inflection. Next, we have to substitute what are the points. By the way, these are the values of x, rather. But what are the points? In order to get for the points of inflection, we have to substitute it to the original equation, which is fx is equal to x raised to 4 minus 4x cubed. So let's try. F of x, okay, let us have this one. X raised to 4 is equal to x raised to 4 minus 4x cubed. Okay, so at x is equal to 0, f of 0 is equal to x 0 raised to 4 minus 4 raised to 0 cubed. So we have here at x is equal to 0, the y is equal to 0, the value of the function of the dependent variable is equal to 0. So x is 0 and 0. So this one is 0. So this is the first point of inflection. And the second one is you have to substitute when x is equal to 2. Okay, when x is equal to 2, so we have here f of 2 is equal to 2 raised to 4 minus 4x raised to cube. So by substituting here, the value is negative 16. So at x is equal to 2, 2 and negative 16. So this is the second point of inflection. So this is the second point of inflection. This is the first point of inflection, and the second point of inflection is 2 negative 16. Alright, so the fourth step is we have to find for the third derivative test. So what is the third derivative test? So in the third derivative test, okay, from second derivative, we have here the equation is this one. In second derivative, we have here 12x squared minus 24x. Okay, 12x squared. Okay, from double derivative, x is equal to 12x squared minus 24x. So if we're going to test using the third derivative, we have here 24x. Okay, this is 24x minus 24. Right. Okay, so 24x minus 24. So at x is equal to 0, so we have to substitute here. Third derivative, 24 times 0 minus 24. So this is negative 24. So negative 24 is not equal to 0. So therefore, we can say that this is the point when x, the value for x is equal to 0 is the point of inflection. And the second one at x is equal to 2. So we have here in the third derivative test, we have here 2 is equal to 24 times 2 minus 24. So we have here, the resulting one is 48 minus 24, that is 24. So 24 is not equal to 0. So therefore, this x, the value for x is equal to 2 and x is equal to 0 are the point of inflection by the third derivative test. Okay, that's all about problem number 1. Okay, let us now proceed with problem number 2. So find the values of x for which the curvature y is equal to 3x raised to 4 minus 4x cubed plus 1 has a points of inflection. So the first step that we're going to do once again is find the first derivative. Wait. So first derivative is this one, f of x. Okay, let us have this one as our f of x is equal to 12. In this following equation, 3x raised to 4 minus 4x cubed plus 1. So the first derivative of x is equal to 12x cubed minus 12x squared. Okay, first derivative is equal to 12x cubed minus 12x squared. So in the second derivative test, this is the second step, first. So we have here x is equal to, this is 36x squared minus 24x. So now in the second derivative, we have to solve for x, and we have to equate, set this second derivative is equal to 0. So first is we need to factor this one. So I have here 12x minus 12x 3x minus 2. So we have to equate this one, 12x and 3x minus 2 is equal to 0. So 12x is equal to 0 and 3x minus 2 is equal to 0. So you have here x is equal to 0 and x is equal to 2/3. So these are the possible point of inflection. But we have to test this one, whether this one is really the point of inflection. So we have here, okay, the point 0, this is 1, and this is 2/3. So these are we have to create for the interval here. The interval would be, okay, open to negative infinity to 0. Next is the second interval is 0 to 2/3. And the third interval is 2/3 to positive infinity. So this is the first interval, the second interval, and the third interval. Okay, let us now have the interval, the test, and the table. So using the tables here, interval, okay, the test, the second derivative, and concavity. So the first interval is negative infinity to 0. The test is negative 1. So we have here double derivative at negative 1 is equal to 36 times negative 1 squared minus 24 times negative 1. So that's equal to 60. So second derivative is of x is greater than 0. So therefore this is concave up. Okay, this is up. And in the second interval would be 0 to 2/3. Okay, what else? What are the tests? The test or the test that we're going to use. So it's up to you what is the test that we're going to use. And at least that is between the interval. So this is 1/2. So second derivative 1/2 is equal to 36 times 1/2 squared minus 24 times 1/2. So the resulting one is negative 3. So we have here, by using your calculator, 36 1/2 squared minus 24 times 1/2. If we're going to use your calculator, we have here, the second derivative of x is lesser than 0. So therefore this is downward. And the third one is 2/3 to positive infinity, open. So when 2/3 to positive infinity, it could be 1 because that is between the interval. So double derivative here, 1 is equal to 36 times 1 squared minus 24 times 1. So the resulting one is 12. So therefore the second derivative is greater than 0. So this is upward. So if we're going to look at the interval given, the interval is does it change or it changes from positive to negative. So therefore, this we could say that these values of x is equal to 0 and 2/3 are the values of x of inflection. So we have checked already using the second derivative test. So now let us now find the point of inflection by substituting it to the original equation, which is f of x is equal to 3x raised to 4 minus 24x cubed plus 1. At the values of x is equal to 0 and 2/3. Okay, so the equation is f of x is equal to 3x raised to 4 minus 4x cubed plus 1. So at x is equal to 0, okay, at x is equal to 0, we have to substitute simply here. F of 0 is equal to 3 times 0 raised to 4 minus 4 times 0 cubed plus 1. So that's equal to 1. So the first point of inflection is 0 and 1. And we have here the second point. We have to look for the second point. Okay, so f of x is equal to 3x raised to 4 minus 4x cubed plus 1. At x is equal to 2/3. So by simply substituting in the first, the original equation, 2 thirds, so 3 times 2 thirds raised to 4 minus 4 times 2 thirds raised to cube plus 1. Okay, so if you're going to use your calculator, we have here, the resulting one is 11 over 27. So the second point now is 2 thirds and 11 over 27. So this is the second point. And the first point and the second point of inflection. So now let us proceed now with the third derivative test or the third derivative. So in the third derivative, so it should be when you substitute it in the point, the possible point inflection, we can say or we have to look that it should not be equal to 0. Okay, if that is equal to 0, that is not a point of inflection. But it's not equal to 0, that is a point of inflection. That is the value of x or the point of inflection. So using the third derivative test from the second derivative of x is equal to 36x squared minus 24x. So third derivative of x is equal to 72x minus 24. So now, we have to substitute the value for our x is equal to 0. So from third derivative 0 is equal to 72 times 0 minus 24 is negative 24. So this is not equal to 0. So therefore, this is checked in the third derivative that is not equal to 0 because this negative 24. And the third derivative of at x is equal to 2 thirds. Okay, you have to substitute 72 times 2 thirds minus 24. So if we're going to compute, this is 48 minus 24, that is equal to 24. So therefore, this is not equal to 0. So therefore, in the third derivative, so this is not an equal to 0. So therefore, the values of x is equal to 0 and x is equal to 2 thirds are the point of inflection. So that's all about problem 1 and 2. So these are, try this at home. So find the value of x for which the curve of the given function is a point of inflection. Y is equal to x raised to 4 minus 4x cubed plus 4x squared. And y is equal to x cubed minus 3x squared plus 4. So you have to write one in a long bond paper and submit it during our class. So the same format, and God bless everyone for listening.